Hey guys, this is our last video of Unit 5 because it completes Chapter 9, and we're going to talk about acids and bases. Alright, acids, they actually add hydrogen ions to water when they're placed into solution, which makes hydronium ions, which would be H3O+, which should make sense because water is H2O, and if we add a positive hydrogen ion, then it would make H3O+, which gives it a larger hydronium ion concentration. Now, strong acids can conduct electricity. They also can burn your skin or eyes, and these are just some characteristics of them. They taste sour, which remember, we're not tasting these in the lab, but they do taste sour. I'll talk to you about some that you do taste on a regular basis. And they feel squeaky and watery. Now, they also turn litmus paper red. We're going to look at litmus paper. We have red litmus paper and blue litmus paper. If you put the red litmus paper into an acid, it stays red. If you put blue litmus paper into an acid, it turns red. So either one are going to still be red after you dip them in the acid. Acids measure 0 to 6.9 on the pH scale. And I've got a pH scale in your notes, so you can look at it. There's also one in the book that has color to it if you'd like to see that. Examples: vinegar, lemons, and oranges and tomato sauce are what I was telling you. Lemons taste sour and they're acidic. And so those are the type of things that you taste, obviously, not something like HCl, which would be hydrochloric acid. And as you can see, now this is not a rule that works 100% of the time, but 90% of the time, your acids are going to be like this HCl, where they have a hydrogen at the front. And that's what actually breaks off and mixes with water to make hydronium solution. Now let's look at bases. These add hydroxide ions to water when they're in solution. And if you'll remember, hydroxide is OH negative. Strong bases can also conduct electricity, and they also burn your skin and eyes if they are strong. Weak acids and weak bases do not conduct electricity well. Bases taste bitter. They also usually will feel slippery and oily. Now, bases turn litmus paper blue. So if I have a piece of blue litmus paper and I dip it into a base, it's going to stay blue. If I have a piece of red litmus paper and I dip it into a base, it's going to turn that red piece of paper blue to let us know it's a base. Now, bases measure 7.1 to 14 on the pH scale. Some examples are soaps, cleaners, like the all-purpose cleaners that we use to spray off our counters. And then sodium hydroxide is also an example of a base. And if you'll notice, it has an OH at the end. 90%, this isn't 100% of the time, but like 90% of the time, your base is going to have that OH at the end that breaks off and adds to water. Now, let's talk about the pH scale. The pH scale is a measurement of how many hydronium ions are in solution. So, if you have a lot of hydronium ions, you know it's an acid, because remember, acid creates these ions. If you have a solution that does not have a lot of hydronium ions, the solution is a base. Now, some other information to write down. If you add an acid, and I don't think I have blanks for this, so you'll have to write this down in your notes. You can use the back of the notes if you want to. But if you add an acid with a base, you always get a water and a salt. Okay? So here's hydrochloric acid plus sodium hydroxide, which is our base. And that always gives us water and sodium. Well, this one gives us sodium chloride. But it depends on what type. This is the salt that is created in this reaction, but depending on the acid and the base, that will determine what type of salt you have. But remember, we talked about in bonding that the halogens, group 17, when they bond with the alkali metals, that they create salts. And so it can be other things other than sodium chloride. Now, another question that you need to be able to answer is, how do you clean up a spill if we spill a strong acid? And the way you neutralize that, because what you want to do, 7 on the pH scale is neutral, and that's also safe for us to touch. That's where water is. And so if you pour a strong base on a strong acid, That helps you get it closer to 7, and then you can clean it up after that once you've neutralized it. And you neutralize strong bases and acids to get them to 7 so they're not harmful when we clean it up. Now, another way you can neutralize solutions are by titrations. And this is when you start with an acid or a base and you slowly add the opposite one to bring it to neutral. So like if I had a base in a beaker, I could slowly pipette an acid into it, like 1 drop at a time, and continue to test it until we got to a pH of 7. And that helps neutralize it also. All right, this ends our video, and what I would like you to do for your summary is I would like you to find 4 household items in your house and determine if you believe they're acids or bases, okay? And obviously, if you need, ask your family's permission or get their help if you need it, but write down those 4 items and tell me if you think it's an acid or a base. Have a great evening, and I'll see you in class.